Okay, so welcome to today's tutorial. We'll be doing the past paper 2023, right? So let me go here. That's the past paper 2023. And then we'll do the 2022. So yeah, we should push quite a lot. So let me scroll down. Yeah, so this is the question for about basically we did this question, I think it's semester test two, right? Yeah. It was semester test one, if I'm not mistaken. So yeah, let's go to the facade design pattern, right? So we're gonna start as always with the actual UML of the facade. So we're gonna use dear. So why is it called the facade design pattern? Because it creates what we call a facade, right? Which basically means that it hides details. It's sort of like, what's that concept in OOP? Is it abstraction? Yeah, it's similar to abstraction. So it abstracts details and it hides details, the unnecessary details, and they are accessed via what we call a common interface. So, or a unified interface, right? So that unified interface is like it's basically instead of, for example, if you have, let's say you have four classes, and each of these four classes has their own methods, right? And those methods, let's say they do the same thing or something similar. Okay, it's not the same thing. It's different operations, right? Basically different functions. We can unify them instead of calling them one by one. We can unify them by creating what we call a facade, which is a class that calls all three or four of those functions inside one function. Then we call that one function inside the main.java. So basically we unify. So that it's called a facade. If you look at the word facade, right? Um, if you think about the word facade, right? Facade, it consists the word face, right? So it has the word face. So that means you can only see the face and you don't see the hidden things that are inside. So in this case, you can think of like the example I can make is like, for example, a person. When you look at a person's face, you can reach a conclusion of which that it might not be what's actually going inside of that person. So for example, if a person is smiling, you think, this person is a jovial person, is just a happy person. But under the hood, this person is actually depressed. So it's like it creates a facade, like um, a fake appearance, right? Sort of like a facade, a face, a fake appearance, something like that. So you don't actually see the internal state, right? Basically, you don't see um, how things are implemented under the hood. It's like, for example, when you go inside a car, you don't know how the steering wheel is created, right? Because you only see it's like in the slides, was it the slides of that website? I think it's that website. It creates like a front, like something that only the user can visually see. It's like, for example, when you go to a website, right? I get you see the face or the front of the website. So we can say the website is like a facade because you can see that front, all those colors, but you can't see the behind the scenes. So you can't see that, oh, there's HTML, there's what. We only knowing we only now we're only starting to know them now because we are doing computer science, right? But back in the days, I agree, you would visit any website and you would look at the front or the face, how the website looks, basically, without understanding how it works. So that's basically what the facade is trying to achieve. We have multiple, we have what we call subsystems, which is basically those classes, right? In a way, right? Not really, but in a way, you can view it as like we have those subclasses, right? Or child classes. Each subclass has its own method, or its own unique method, right? Then we create one class, the fourth one, which is that one class, that's going to call all of those methods in each of the subclasses. So that means that when we want to use those methods in those subclasses, we use them via what we call the facade, which is the fourth class, whereby that class hides the internal details, basically how each of those subsystems or those classes implements those functions. We call it via a different function, right? So that's basically what we're trying to achieve here. So the design pattern to the UML is actually very simple. We have what we call a facade, which is the class that we're going to create that calls all the other methods, right? And it's a structural design pattern. Basically, it's based on the structure, which is basically the interaction of classes, not necessarily the methods like the visitor design pattern. That one is behavioral. This one is structural. It's based on how we're structuring the classes and everything. So here we're going to have an operation or a function that we're going to call unified operation. Unified in the sense that it's combined, right? We've made it we've unified it and made it a unit, right? Like one thing. So that means when you want to call those functions, right? You call them via this facade or this front, but you don't see behind the scenes that this function actually calls other three functions. So that's basically what it does in a way, right? In a way, you can view like a facade design pattern is like creating a separate main class and then calling that separate main class called the facade inside the main class. Because remember how we use those classes, right? Like we create instances of each class inside the main, of which that's the exact same thing we're going to do inside the facade. So the facade technically is similar to the main. And then we're going to have what we call a client, which is our main class, right? So this is our client. I was also supposed to include client in the visitor design pattern, but it's fine. So this is our client. Then we're going to have the different subsystems or the different classes. In this case, we have different checks, right? So there's three. So it's fine. You can have as many classes as you want, but for this example, I'll use three. So you're gonna have the first class. Um, I'm gonna call it class one, right? I don't have something. They don't have a fancy name to use there. So this will be some operation, right? It does some function. And then we're gonna have a second class. All these classes, we call them subsystems. So I should actually be called subsystem one, subsystem two. Yeah. So let me do that. Subsystem one. And then this will have another operation, right? So other operation. By other, I mean it's different. It's a different function from this function. That's why I use other. And then here we're gonna have a subsystem. Wait, I was supposed to say subsystem two, né? Yeah, this is supposed to be subsystem two. They're just classes, but then they use the terminology subsystem, right? And then copy, paste, and then subsystem three. And then this operation is also different. So this will be another different operation. So I'll call this different operation. And the facade is actually not an interface, even though they use the terminology that we create what we call a common interface. But it's not actually an interface, the facade itself. It's a class. So all of these subsystems, right, we call their methods inside the facade. So that means the facade would actually have instances of these classes. So basically, we're going to have composition. So I actually have to create the attributes here. So I'm going to call this system one of type. It depends on whether you want to create arrays of each subsystem. It's up to you. It depends. But in this case, I'm not going to create arrays. I'll just create it as just instances. I'll just make them private because my bad, I was not supposed to exit. So subsystem one, and then adds another object, subsystem two, private, and then add another one, system three, which is of type subsystem three. Make it private. then apply. So these are the systems, right? I'm declaring them there. Why? Because we need to call these methods, right? We can only call these methods by creating an instance because all of these methods are instance methods, right? Meaning they're based on a specific object. So we need to actually create objects to call those functions. That's why I create objects inside the facade so that all these functions are called inside of this one function. The client is going to use this facade, basically this face, and won't know about all of this, right? So in a way, this creates what I call a facade, like a front, right? So I'm gonna have to do composition here, right? If I'm not mistaken, I hope but then it's the one I was looking at the diagram. This is how it looked. I think it's up to you how you make it, whether you make it use composition but it has to be composition somewhere because these objects are going to be contained inside of that facade. So all of these are contained inside of the facade. This facade is going to be used inside the client. So basically the client is associated with a facade. So we're going to do association here. How come it's not, what's going on now? Let me put it here. Yeah. So the facade is associated with a client. Yeah. So this is basically how it's going to look, that facade, the facade design pattern. You're going to have multiple subsystems, right? It's up to you how many subsystems you're going to have. In this case, in the question paper, we have 3 classes. So 3 sub. There's an image so that I can share it with you guys. So this is facade. So I'm going to call it facade design pattern, right? Cortex Academy, and then save. So this will be this is the model we're going to work with, right? So let's go to the question paper now. Provide a UML class diagram for the facade design pattern. Oh, they said UML. It's very, hey, so we're cruising nicely here. So at least you only have to provide the UML. You don't have to implement it. So provide a UML class diagram of the facade design pattern. Apply to the following problem. So you have taken over the maintenance of an old accounting system that has 3 classes. So those 3 classes, we call them subsystem. Why subsystems, right? Let's try to understand why they chose the word subsystem. A full system, right? I agree with that's a full system. That we call that the system. In this case, it's the accounting system, of which it uses 3 functions to achieve or to get that system, right? So since it uses 3 classes, we can view those 3 classes as like minimum, what is mini systems, right? Basically small systems that we combine together to form one big system, which is the accounting system. It's like, for example, you're playing that puzzle game whereby you buy all those puzzle pieces and then you put all of them on the floor and then you combine one by one until you get the full image, right? So that full image, we would call that the whole system. All those small pieces you're adding together, we call those subsystems, which is basically small, it's like small fractions of the full system. So in this case, it uses 3 classes which actually build the full system. So those 3 classes are called subsystems. Subsystem just meaning it's like we've broken the system down into smaller chunks, into small pieces. And in these pieces there are 3 pieces or 3 classes. So I hope that makes sense. So let's try to do the YAML based on, remember the design pattern, right? This is how it looks. It doesn't mean you're going to have classes called subsystem. No, you need to apply the design pattern to your problem. So let's apply that now. So let me see let me just double check something. Oh yeah, I can still export. So I'm going to export because I exported, English, I exported the template, which is this. This serves as like a template. So we need to update the template and apply it to our problem. So our problem, if you look at our problem, it's an accounting system, right? And it has three classes. The client software requires a simpler way to interact with these classes. Remember what a facade design pattern does, right? It gives us a sort of like a common interface whereby the client has a simpler way of interacting with the system. By simpler way, it basically means that instead of calling get balance and then they call get details, then they call get fees, you simply call one method, and then that one method, right, that you call, it calls all three of these functions. And the class that has that one method, we call that the facade, right? Because it kind of provides an interface. Basically, it provides one function that we can call, which doesn't describe how it does how it does how it executes that thing, right? For example, if we're getting those details, when you call that function, we don't see how it calls the balance and the details and the fees. We can't see. So it acts as a facade, like a front, right? So let's update our UML. So I'm gonna go to this facade. I'm gonna rename the facade class. Remember, you need to apply it to your problem. If you look at here, right, we have balance detail, we have a balance class. Okay, the way I would approach it, right? Remember, we have a balance check, details check, fees check. Like I said, it's kind of similar to like inheritance in a way, technically, but not really. But because we are doing composition here, so we're gonna have, we see they all end in check, so they're all types of checks. So I'm actually gonna call my class check facade so that it applies to the problem that this is a facade about checks. So check facade. And then the attributes, it's basically instances. Remember, you see that I'm updating the template to apply it to the problem. That's what they mean. So don't basically use the names that you see on the UMO diagrams on the slides. No, you need to take that template on the slides, apply it to your problem. So I've called it check facade, right? Um, yeah, check facade, then it needs to take in all these instances. Why are we passing the instances? Remember, these are instance methods. So that means they can only be called via objects. So therefore, I'm forced to create objects of all these classes inside of the facade because I want to call these methods inside that one method. So I'm gonna go here. I'm gonna call. We have what do we have? We have balance check, right? So this would be balance check, and it's of type balance check, right? That's done. Then we go to the next subsystem. We have fees check, and then we have details check. So details check, that's the name of the variable. The type is details check. And then the next one is fees. So it's fees check, and then fees check. And then that should be it. So these are all the checks, right? And they're gonna be called via this unified method. Remember, it's called unified in the template because the template is supposed to give you like a hint on how the design pattern works and how to what this function is supposed to store. So don't call it unified operation. That's wrong. You need to apply it to your problem. If you look at this, each function, what it does, right? Remember that I'm supposed to create one function which calls all the other functions in each of the classes. The function that I'm supposed to create, it needs to have a name that describes what all those three functions are doing. So you see all these functions are getting a balance, details, fees. So they're getting info or data, whatever. But in this case, it's going to be processed at that time, which I think it should be processed. So you can call the function get info. So get information or get info, whatever you want to call it. I'll write information in full and then apply. and then done. So now the facade is done. I've applied it to the problem. You see, it's even called check because it's a problem based on checks. And then we need to create the subsystems, which is basically each of the classes of which these instances we are storing, right? So each instance must have its own class. So we're going to start with balance check on the side. So this is balance check, right? And then it has which function? It returns a double. It's called get balance, it takes in a client ID. So it's called get balance. So I'm going to rename this from operation to the actual name because I need to apply it to my problem. So it's called get balance, which takes in a client ID, which is a string type. And then apply, then okay. And then we've applied that. Now we go to the next class. So we need to have a class here for the details check. So details check. And then the function for the details is called get details, if I'm not mistaken. Yeah. And then it also takes in a client ID, which is of type string. Then apply. And then the next subsystem is this one, which is the fees check. And then the operation, we need to rename it. It's called get fees. And then it takes in client ID of type string. Let's double check something here. Okay, so yeah. So we have all those classes, right? So I'm going to shift this to the right a bit. Yeah, and then this, move it down a bit. So this will be the client. Yeah, and then we're done. That's basically the UML. There's nothing more to add here. That's basically the UML. The thing is, the reason why it's 15 marks, ne, is the fact that most of the marks though point to you knowing the diagram, whether this should be an interface or class, whether these are the classes or interfaces, or you also remember to put client. You also use the right notation. You also put in the right functions and everything. That yeah, that's very important to understand. So this will be the full UML, right? So let me see here. So we need to do code. So I'll basically open Microsoft Word and then copy and paste this into Microsoft Word. Since we are now doing past papers, because at the end of the day, I need to generate a PDF with all the answers. So this will be question 3, if I'm not mistaken. So let's check, is it question 3? Yeah. So design patterns in UML. So now I need to save this UML as an image, and I'll use SVG because I don't want to lose quality when they zoom in. So I'm going to choose Cairo, save it on desktop. Save it as diagram facade, then save it on desktop, then go to my Microsoft Word, go to insert, click on pictures, click on this device, then go to the location whereby that image is saved. It's still loading. It's taking a bit of time. Then I've called it diagram facade. So there it is. And then there's the facade, right? Design pattern. Then we go to question 4. So yeah, you just need to actually, to be honest, you don't actually, I'm looking at it, right? I was thinking about the design patterns. And I realized you don't actually need to think about it that deep. You can just focus on the slides. But then you need to really understand what's going on. Because if you want to cram, it's a problem because one mistake, because some design patterns are similar. One mistake, you think it's that design pattern when it's not. And then you get wrong marks. So let's not do that. Oh, my bad. This is incomplete in a way. In a way, not really, but in a way. Remember, we want to unify these functions and look at all these functions. They take in a client ID. So the get info which unifies this, and it also needs to take in a client ID, or else it won't be correct. So client, like 100% correct. So you need to take in the client ID, and then yeah, now it is perfect because we need to unify these operations or these functions, right? So instead of calling them one by one, we can call one. And if you look at all these functions, they take in a client ID. Basically, they get the information for that client with that ID. Basically, to find out what's their balance, what are their details, what are their fees. So yeah, I needed to fix that. So let me save. No, not that type of save. Okay, I have to export it again. This is kind of a drag. So let me save it as diagram too. Yeah, you still get your marks. Maybe it's all about your luck. Some tutors might give you marks even though it's actually not 100% correct. So yeah, but then I wouldn't want to take those chances. Don't take chances. Just do everything perfect. So there's the DMO. Then let's go to question 4, right? Which is something we've been doing for a very long time. If you guys remember semester test 2 when we are preparing. So analyze the UML class diagram below. Provide Java source code for the following task. You can assume that all relevant packages have been imported. What that means is that they shouldn't see any line in your code that starts with the keyword import, because they said assume everything has been added or imported. So that's very important to understand. So we have yeah, remember this is okay, this is okay. It didn't tell you, but I can tell that this is binary because I see it implements the serializable interface. In order for something to be serialized or saved to binary, it needs to be serializable, right? Meaning I'm able to serialize it. So since this is implementing the serializable interface, then we know for a fact it is binary IO, right? Because it's only this serialization only applies to uh, serializing by objects to a binary file. Or another word for serializing is to save the objects to a binary file. We say that they are serialized. So Brick Corporate of Utopia has requested that you assist them with processing the data for their boxed sets project. In order to accomplish this task, you're required to create a load box set method. So we need to create that method right there. I don't know if I still have VS Code. I don't. So we're gonna use Notepad. It's fine. We'll use Notepad. So I just need to change the language to Java so that it colors in when I put in when I type Java reserved words like the data types and things like that. So it should be called create what is load box set. And notice the capitalization and everything needs to match. Only this method is required to complete this task. They told you only that method. And it's worth 15 marks. To be honest, this is not bad, Shem. Once you really start, you realize it's not bad. So this function is called load box set as it is there. That's why I just simply copied and pasted the name. And then it takes it as the following signature. By signature, they mean the parameters. We say this is a function signature when it's like this. So for example, when you have the function name and its a return type, for example, void, and its parameters, right? Including their data types, followed by a semicolon. It's not an implementation. So it looks like this. That's why I'm putting a semicolon there. We say that this is the function signature. So the signature includes the parameters too. So by signature, they're telling you about parameters. So the parameters that's required is a file handle, pointing to the file that it needs to read from. So we need to take in a file handle. So I need to replace this with a file handle, right? And then the return type, what should it return? The method will return a boxed set instance, right? So basically something of type boxed set. So I'm going to copy this exact same name, replace it here and put it there. And then since we need to implement this function, I'm actually going to put the curly braces because I want to see the code here. They didn't talk about anything static. If they had told you about making it static, you put in the keyword static, but they didn't tell us. And we need to make the function public, remember, so that it's accessible. So public boxed set load load boxed set, right? So since it returns a boxed set, we need to create or declare boxed set instance, right? Or boxed set variable. So boxed set instance. So boxed set, I'm gonna call it boxed. This function returns it, so at the end of the day, we know we're gonna have to return that boxed instance. And then in between here, remember we did talk about file handling. If you were cramming, go back and watch the recordings. So the load box set method, right? It must read the boxed set and corresponding bricks from the binary file using ARM, right? So we are reading the boxed set itself. As you can see, this is an instance, it's an object. So the classes we're going to use is object input stream because we're reading objects and the corresponding bricks, you see, objects. But then it can be tricky, right? Let's finish reading. But so far, after reading this, I'm assuming that we're actually reading the physical objects themselves, not the primitive types. But assumption is a bad thing, right? Don't assume. Don't think for them. You need to finish reading the question. So first, the set number must be read. So there's a set number. I don't know what it is. Okay, there it is here. It's a string. So we're gonna read a string first, followed by an int, which represents the number of bricks that exist for the boxed set. Then finally, you read the brick data. So let's do it one by one. So let's start here. You see here. Remember, in order to read from the binary file, we need to use, yeah. If you need to go and do revision, remember when you use the classes object input stream or object output stream, you can read both primitive types and actual objects. So don't be surprised and ask yourself, how did they expect you to read an integer, blah, blah, blah. They expect you to understand what's going on. So since I understand, I know that I'm going to need to remember try catch, and it always throws an error, file not found, right? It always throws two types of errors. We have file not found and IO exception, meaning there was an IO exception. IO meaning input output. Input output because they're trying to read from the file of which that counts as input into the program, right? So we need to catch that exception. So we're gonna catch the file not found exception, EX, and then I'm gonna print out the error. So system.out.println. I don't want to print the stack trace, right? So I'm just gonna print the message. So I'm gonna use this instance EX of type file not found. I call the get message method. So get message method. And then I'm gonna catch the other exception, IO exception. I'm gonna call it E. And then I'm gonna print out it's supposed to be an error, so system.error. And then E.get message. So that you don't see a weird output. So this should be an error, ERR. If you print stack trace, right, it's a message that the user cannot understand. So that's why I'm actually printing a message, not the stack trace itself. So let's start. So remember the file class, right? It helps us to create a connection to our file. It's like, for example, Bluetooth. Before you can share files, right? You need to do what they call a connection, a Bluetooth connection. So you need to pair. So that's what we are doing. We are pairing with the file to establish that connection. But since the file class doesn't have methods to read and write to and from the file, we're going to need to use other classes that help us to do that. So we obviously going to start with the file input stream. Why input stream? Because we are reading. This function reads from the file. So basically, if you are reading from the file, it counts as input because the Java or your basically this function, it receives that information from the file. So technically, it's input, right? So I'm gonna call it f in as equals to new file input stream, and then it takes in the file handle, right? So handle, and don't forget the semicolon, right? And then press enter, and as you can see, there's the closing bracket for this, right? Because I'm using ARM, and then we need to buffer it. So buffered input stream, buff in. I'm just gonna call it buff in. Is equals to buffered input stream, and then I pass in the file input stream, so f in, semicolon again, and then press enter. Then remember we're reading objects. So we're actually reading both primitives and objects, and the object input stream can do that. Even though its main purpose is to read objects, but it also accommodate reading primitive types. So I'm gonna say object input stream, obj in is equals to new object input stream, closing brackets. Then you're gonna put in the buffer here because we're gonna read from that buffer. And then now this is how it looks. As you can see, we've done everything so far, right? That's needed to set up our functions so that we can, or our try catch so that we can read from the file. If everything goes well, that means it's not gonna reach those parts, right? Then we can now read from the file. So in the question paper, they said you need to read let's read one by one. They said read the set number, which is a string. So read the set number. So it's a string, so I'm gonna get back a string. So I'm gonna call it set number because I'm reading a set number, duh. So is equals to object in dot read. Remember, we talked about this. We use the UTF function. And then if you go here, after that, you read an int indicating the number of bricks. So also name it number of bricks. So read the number bricks. So it's going to be int number of bricks is equals to obj int dot read int because I'm reading an integer. And then now I read information for, not real information, but data. Read data for each brick. Remember the boxed set, right? It is a collection of bricks. And to be honest, that's why they didn't, if you check here, right? That's why they didn't talk about this, right? They didn't list the variables and functions because we don't need to know about bricks because the main important thing is the box set because it should return a box set. So let's notice something here. Remember, we need to still instantiate a boxed set because it's a reference type. It's instantiated. So here I couldn't instantiate it, so I'll actually initialize this to null here. But remember, in order to instantiate it, what parameter do I need to pass is the set number. So I'm going to go to the line whereby I read the set number here. Immediately after reading the set number, then I now have the set number, so I can instantiate the object. So now I can instantiate the boxed set. So boxed set. So let's instantiate it. I'll call it boxed. So boxed is equals to new boxed set, which takes in a set number. And remember, computers read from top to bottom. So that's why I started by reading the set first before I instantiate it. Remember, if you don't instantiate, this function is gonna return null, of which is gonna cause it to crash because you're gonna try to call a function from this null variable, which will throw what we call a null pointer exception. So we need to actually instantiate it at some point, and of which we did. Then now we need to, they said after getting the number of bricks, right? You then finally read the brick data, meaning one brick at a time. So I'm gonna go back to my code here. I need to read the brick data. Remember, there's more than one brick. So I'm gonna actually use the for loop. So int I is equals to 0. I is less than number of bricks, I plus plus. And then I'm going to read the number or read the brick, right? Which is the object. But then remember, it returns when you read the object from the using an object input stream, it returns it as type object. So there's casting that's needed to be done here. So I'm gonna save it as object. I'm gonna call it obj what? Obj temp. Let me call it obj temp is equals to obj in, right? My object input stream. I read the object by calling the read object method. So dot read object, right? But then it's of type object. And in order for me to put inside this box set, because remember this box set, right? It is a list of bricks. And we can add one brick at a time by calling the add the brick method, which takes in the brick to add. So I'm going to use that method. But then remember that brick it takes in, if you look at this code, it's of type brick. So I need to cast this object, this type object to type brick. But before I cast, I need to check if it's an instance of a brick, meaning it's of type of brick before I cast it, because I don't want to try and cast things that don't make sense. For example, you can't convert a chicken to a car, right? So that's why you need to check first what type it is. So we need to use instance of. So if obj temp is an instance of, basically it's a type of brick, then I know it's safe to cast. Then I'm going to cast. And when I cast, I'm going to get back a brick, right? So I'm just going to create a brick variable. So brick is equals to, and then I cast to type brick. What am I casting? I'm casting obj temp. Then once I have the brick now and it has been casted to the right type, I can now add it to my boxed set, using the add brick method. So add brick to boxed set. So I'm gonna use the boxed set, so dot add brick, and then add that brick. And then done. You're basically done with that question. There's nothing more to do. Yeah, that's pretty much it. So yeah, since once you have, if you did attend that, watch all those recordings and you're paying attention, this shouldn't be hard. As you can see, it doesn't take too much time either. So let me take a screenshot of this. And then let's wait for it. Yeah. And then I'm gonna take a screenshot of this. So this is the answer for that question. Go here, paste it. So this is the code, right? And at least I put comments there so that you can understand. So we're done with question 4. Let's see if we can do another question. Let's go to the top and see what questions we have. Java FX, not now. I need to go revise a bit, but I do understand what's good. I still remember some things, but I don't want to take chances. For example, if I'll choose a class, right? It's a class that helps you to basically it's in the name. It's a class that helps you to choose a file, right? It's a class that we use when you want to create an application whereby the user has the ability to choose a file. So for example, if you remember when you go to anywhere on the cloud, then you want to upload something, agree, you choose upload. Or for example, you want to send a file via email. Agree, you click that. There's this icon that you click to add the file to your email, right? To that email you're trying to compose. So that button that you click and it does that pop-up. That pop-up it does, it's using what I call a file chooser class to help the user choose a file. So here, that's why I said the answer is in the name itself. And then name any and discuss any two layout managers, right? By layout managers is things like read pane. What's the other one? Stack pane. Yeah. And then you discuss what are the differences. Basically, how do they arrange things on the plane? On the how do you set up nodes on each of these layout managers? So we have something called nodes. So I'd advise you go in and watch that recording of JavaFX. So this one will touch it tomorrow. And then let me see if I can answer this one. Oh yeah, oh, this question is actually, this paper is short. It's actually 4 questions. That's nice. So let's do question 2. Then tomorrow we'll do question 1 and another paper. So Java programming concepts, right? So define a definition of an assertion and discuss where it is used. So the way I would define an assertion, right? An assertion is basically a way for you to terminate the program if something went wrong, but you don't provide the information on how to handle that case, like when that problem occurs. Basically, you check to make sure the variables or inform or data that you're getting from the user is valid, meaning it's in the right range, it's in the right format that you want it to be. But if it happens to not be in the right format, assertions don't provide the ability to solve those issues, right? Basically to fix the data if it's not in the right format. Unlike things like exceptions, right? You see exception handling, you can catch an exception and actually solve it and fix it. So that's they might, if last year they asked about this, right, about assertions, maybe they might ask about an exception, like explain what is an exception and discuss where it is used. So let me discuss the assertion, right? So assertions, an assertion, right? I need to write proper English here. An assertion is basically the programmer putting safety measures to make sure that the program works as intended, right? As intended, it means that in other words, you can also add more information like for example, the data entered by the user is in the right form or right format, right? Basically, assertion is to make sure our program works the way we intend it to work. But we're not done with explaining, right? Remember what I said, the difference between assertions and exceptions is that with an assertion, you can't handle that. You can't fix the problem if, for example, the data that we're given by the user is not in the right form. We can't fix it. It actually terminates the program, which is kind of a problem, unlike with exceptions. Exceptions, you can throw a problem or basically throw an exception and then catch the problem and provide a solution. So that's the difference between assertions and exceptions. So here we can say but does not provide the means to fix the issue, right? If a problem was found. It doesn't provide the means to fix it if it found the problem. That's the difference. And then where it is used, right? For example, they need to define where it is used. Assertions are used in debugging, right? When you're debugging your program. Because when you're debugging, it's basically testing. You can say debugging or software testing. By software testing, right, we mean like I said, English is very important. That word is actually self-explanatory. Software testing. We are testing software. What is software? It's the app. So you're testing the app to make sure it works. So that's where assertions are used. In software testing or debugging, you're basically looking for bugs or errors, which is synonymous to software testing. It's synonymous because when you do software testing, you are bound to find bugs, which is technically the same thing as debugging. So that's why I say they're kind of synonymous. So that's assertions. And then B, what is B about now? Let me answer B. And then B, analyze the Java code segment and answer the question that follows, right? So we have a class, blah, blah, and it has another, they've declared another class. Provide the source code for instantiating an instance of food item from the outside restaurant class. Source code for instantiating a food item from the outside of restaurant class. Oh, so basically they said they want you to show how you can create an instance of this variable outside of this class. So basically don't instantiate it inside because there's a huge difference between instantiating it inside this restaurant class and outside. If you instantiate it inside restaurant class, it's simple. You simply say food item is goes to new food item. They want to test what we call inner classes. This is a chapter on inner classes on the slides. You must understand that. So if I still remember very well, I'm not sure. Let me see. I think I do remember. I think I kind of see. I hope you can double check on the slides. So I'm gonna delete this and then let me try to instantiate it. We're going to create a food item, right? So food item, I'm gonna call it food item is equals to new. Yeah, I think this is the proper way. If I did that other way, I don't think it's gonna work. I forgot the anonymous inner thing. I just not sure what syntax, but I'll just use what I assume is gonna work here because I'm thinking of two ways you can answer this. I don't remember seeing. Maybe it's in the textbook. I'll double check in the textbook, but I don't remember seeing anonymous. What is not anonymous, but inner classes. Basically, you have a class inside of another class. So inner class. So public food item is an inner class. So since I want to instantiate food item, do you understand do you see something here? Food item is inside what? Restaurant. So I actually need to say new restaurant, right? Did I spell it correct? Yeah. Restaurant, but I want the food item, right? So I need to say restaurant dot food item. So dot food item, and then the parentheses, right? The round brackets. So this is how you instantiate it, right? If I'm not mistaken, you can just double check on the slides. This is a topic based on inner classes. So on the slides, look for something that talks about inner classes. And I like provide the source code for instantiating an instance from outside. I guess there's a lot of marks for this because they're giving you a whole 4 marks just to demonstrate that. And then there's something that we call type erasure. It's actually found in generics, right? Which is templates, generic programming. When you say of type T, it uses something that we call type erasure. What is type erasure? So I'd actually have to demonstrate it. Before I do that, let me copy this, save this answer. I hope I still remember it. If I still remember it, then at least I can know that the pills that I'm taking for memory, they're working. if I did put it in the right way. I hope I didn't make any mistake here. And then C, what is type erasure? So I need to actually demonstrate it. So let's think about let me see, what example can I make? Let's say you have a class. Let's say a class that does an addition, right? It adds numbers. Let's just look at that class. So public class add. So since it's adding numbers, right? It's gonna have a number. So some number, but it needs to be able to add any number or anything, even concatenation. So that means I need to actually use type T because I can't say int here. I can also say string. I can also say double. It needs to be any type. So I'll make it generic. So to make a class generic, you simply add the angle brackets, which is these two symbols, after the name of the class. And then within those symbols, those angle brackets, you put in T, which just means any type, some type. So that means now when we have this class, right, I'll show you right now, right? I'm not gonna do anything special. I'm just gonna leave it as it is because I want to explain type erasure, nothing more. So now when you're inside your main.java, right? Let's say that's where you're calling this class. So if you're inside main.java, the way you can create an instance of this, right, is that it's called add, right? That's the name of the class. But it takes in a generic parameter. So I need to pass in the type there. And the type that you're allowed to pass there, it's only reference types. So that's why you might ask yourself, Mara, what about primitive types? Remember, primitive types, they have what we call wrapper types. Basically, we wrap them around those types so that we get reference types of basically each primitive type has its own specific reference type. So if I want to add two integers, right? So that means I'm gonna say type T is gonna be integer. I use the wrapper class. So let's call it add integers because it adds integers. And then I instantiate it. So it's goes to new add. Obviously, everywhere you instantiate it, it's followed by this angle brackets because that's how we declared it. You see, this is how it is in full. So here you also have to pass in the type. But then due to Java updates, you can now omit the type only after the assignment, the right-hand side of the assignment operator. But on the left-hand side, you must provide all the types, the type there. Then you put in the brackets for the constructor. There's nothing too different here. Notice something. This is how you'd actually instantiate it right before. But then remember it's declared like this. So I need to put in those angle brackets like this. So what is type erasure? Right? If I have these two instances, right, and then this one is called double sh. Okay, let's say string concatenation, so string. So when you see these two classes, right, remember the main important goal for generics, right, generic programming is to pick up errors at compile time instead of runtime. Because if you pick the errors at compile time, we can actually prevent a lot of errors that may occur at runtime. Remember, at runtime, it's when the program is running. At compile time, it's when the program is compiling, basically translating Java to machine code. That's the compilation process. So with generics, we're able to pick up errors during that process when it's translating Java to machine code. Because what happens? What happens is that generics uses something that we call type erasure, which basically means, as the word suggests, like I said, you must understand English. Type means data type. Erasure is a word that comes from the word erase. And erase means to basically remove, right? So what does it mean by that? It means that it's going to, when it sees this part over here, right? It looks at the type you've passed here, and then it goes to the generic class and it does a type erasure. It erases the T everywhere where there's a T with the actual type. That's how generics is able to actually accommodate any type because it uses something that we call type erasure, whereby it goes and replaces all the T's that it sees with the actual type that you've passed. So that's why it's able to work if you pass integers, and it still works if you pass string. Because you see, this is how it looks like when it reads line 6. That's how the type erasure will work. Then when it reads line 7, the type erasure does this. It takes that string and then it erases it here, right? So that's what we call type erasure. So yeah, I'm just going to copy this as an example for that question so that you can remember. Right, so copy this and then paste it here. Then define type erasure in my own words, right? So type erasure is when Java erases the type T inside the generic class. Um, you can say before runtime or you can say during compilation so that errors can be detected at compile time. Because it could have done this type erasure at runtime. But then that's a problem because we're going to pick the errors when it runs, which is a problem because we might not pick the errors when we are running it, but it actually gets picked up by people who buy our app, of which they're going to leave very bad reviews on Google Play Store or Apple Store. So that's why all of these things are very important. We need to make sure that we pick them up way before we release the app to the users, to the public. So type erasure helps us to pick up errors at compile time. And what it does, right, it erases the type inside the generic class during compilation. So it erases that type, basically the type that you pass here when you actually create an instance of that class, of that generic class. In other words, you could say, technically, but remember, there's many ways you can phrase it. You could say that type erasure erases the type T variable type T inside the generic class with the data type. I would you need to phrase it in the Java way. We shouldn't say data type. We should say this. Remember, when you pass the thing that you pass in here is a reference type. So it replaces it with the reference type passed when that instance of this class is instantiated or declared or created, whatever you want to call it. I'll just say instantiated to use proper terms, right? So that's pretty much it, right? So that'll be it for today's session. Then tomorrow we'll just I need to do a quick refresh on this. Shouldn't take me too long, but I don't want to just go on something without being prepared. Yeah, so that's it for today's session. I guess we'll continue with this paper tomorrow, question 1. Then we'll start another paper. So I think we're going to do the 2022, right? So let me check so that you can go and prepare or go practice on your own first. So with this one, remember the main goal here, that something that's a bit new is the design patterns. That's the rest is kind of obvious. It's self-study. And some of them we wrote them there. So let's see. Oh, here they didn't tell you. You see, it seems like they didn't tell you. Um, it asks you to design a game where a hero is trying to avoid monsters while collecting coins. When each monster enters the screen, they are added to the list of monsters that are observing the heroes out there. Here they gave it away. It's an observer. They said observing, but most of the time they won't give it to you. I don't know, maybe they'll. So go study the observer design pattern. So that's it for today. Hope you guys have a lovely evening.